Hi, Jalen and Haley. This is section 5 for indirect proof. It sounds really yucky, and it kind of is a little bit, but it's not too. I mean, the homework assignment is short. So, indirect proof, another name for that is something called proof by contradiction. 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 Do you know what it means to contradict something? Like saying the opposite, right? Okay. So what we're going to do is when we're trying to prove something, and you guys might have done this before, like if you're arguing with a friend or something and one person thinks they're right and the other person thinks they're right, you would be like, okay, well, let's assume that you're right, right? Okay. And then I'm going to prove you wrong, right? So what you're doing for a proof by contradiction is you're assuming that the opposite is true. Like whatever your friend says, okay, I'm like, okay, I'm going to assume that what you're saying is right. Now I'm going to show you why you're wrong, right? It's a proof by contradictions. You assume what they say,
so like Luke with
and
us.
then kind of like Luke with us, yeah, every day. So Luke is good at this because he likes to argue a lot. So proof by contradiction, you're going to assume the opposite, and then you solve it and find out why it's incorrect. Okay, so there's 4 parts to this. I'm going to give you guys a speaking part, and we'll go through this. And these are really good illustrations of the 4 steps of a proof by contradiction. Down here they say that there's only 3, but I think there's kind of 4 main parts. So Matthew has the first part, Kim has the second part, Mealing has the third part, and Domingo has the 4th part. So those are the 4 steps of finding an inverse, and we'll write stuff down off to the side over here. So Jake, since you're the only boy, you get to speak Matthew. Will that work? Okay. Who wants Kim?
I think no.
You want Mealing?
Okay.
You want Domingo? You're Kim. Okay, so we've got it all figured out. I'm going to interrupt you. So after you do your speaking part, I'm going to interrupt. We're going to write some stuff down, and then we are going to, whatever. Okay, so Matthew, go.
I'm almost positive Friday is not a teacher work day, but I can't prove it.
Okay, so they are assuming the first step is like what we're trying to show. What we want to show. This is kind of like your given and prove step. Okay, given, prove. Given, prove. So he's trying to prove that Friday is not a teacher workday. Okay, so let's talk about that for just a second. Friday is not a teacher workday. Okay, what happens on teacher workdays? You don't go to school. So he thinks that Friday is not a teacher workday. So he's saying, I think Friday we do have school, right? Does that make sense? He's saying it's not a teacher workday, which means we have school on Friday. Okay? But then we're going to go to Kim. Kim is Angel. Here you go.
Let's assume that Friday is a teacher workday. What day is our next geometry test?
Okay, so this one we're saying, okay, let's say Friday is a teacher workday. And this is the next step, which is assuming the opposite. Okay? So he's like, I don't know for sure. I don't know for sure if it's a teacher workday or not, but let's assume that it is, right? Let's say that it is a teacher workday. So assume the opposite. We're going to say it is a teacher workday. I don't think it is, but we're going to assume that it is, okay? We're going to assume the opposite, okay? And now we're going to see why that is or is not wrong. Okay, Mealing.
According to the syllabus, it's supposed to be this Friday, but we don't have tests on teacher workdays. We're not in school.
Okay, so the third step is providing some evidence / leading to a contradiction. Okay, and the symbol that we use for contradiction, so we don't have to keep writing the contradiction word out every time, is we do a dash, a C, and an exclamation point. So when you see that in a proof, that just means, hey, look, we proved it wrong, right? We assumed that Friday was a teacher work day, but you're like, okay, we have a geometry test on Friday, though, so that's not going to work. Because if it was a teacher work day, why would she say it was a test on that day? So, contradiction, we must be in school that day, okay? So, Domingo?
Exactly. So that proves that this Friday can't be a teacher workday.
Okay, so we list out the solution. We have said, we have assumed the opposite. We have said, okay, let's look at the syllabus. Oh, wait, that can't be right. So Friday can't be a teacher workday, and that is our solution. So we're restating the solution. So those are the 4 steps that we're going to do for each one of these proofs. And, that's just kind of an illustration. Okay, you guys probably have done this before at some point in your life. You probably do it daily if you're around Luke all the time. because he makes you argue lots, okay? So there's that, all right? Indirect proof is a proof by contradiction. You temporarily assume what you are trying to prove is false, okay? So there's that. They say 3 steps, I say 4. Example 1 is just getting us warmed up. So they're just saying if we were trying to show that angle ABC is not congruent, this guy means not congruent, not congruent, that's what that symbol means. Okay, what would we start out by saying? Okay, what would we say first? If we're trying to prove that is true, right, that it's not congruent, how would we start this proof by contradiction? What would the assuming opposite step be? That they are congruent. So we would just start by saying angle ABC. Let's say temporarily that they are congruent. And now I'm going to continue on and show you why it's false, right? In this case, we don't have to finish the proof out. They're just giving you an example so that you're warmed up to like getting ready for that, okay? So we don't have to actually prove anything here because we don't have a diagram to even go off of, right? But we're assuming the opposite, so we're saying that they are congruent, okay? Now this one's another really good example. If 6 is a factor of n, like a number, right? Give me a number that 6 is a factor of. That means 24. Okay, 6 goes into 24. Then 2 is also a factor of 24. Is that true? Is that always true? If 6 goes into it, then 2 has to go into it, right? We know that that's true, right? But let's say I'm trying to prove it to Libby over here, and I say, okay, 6 goes into a number, then 2 has to go, and she's like, wait a second. No, it doesn't. 2 doesn't have to go into that number, right? Let's say she's going to argue with me. And I'm like, okay, Libby, let's say that you're right. What would I say? Let's assume that, what? What would I start out by saying? If 6, now this part's going to stay the same. Let's say assume 6 is a factor, but 2 is not a factor. So we're still starting with 6 being a factor of a number, but 2 is not a factor. And then I would continue on. We don't have to finish this proof out, but so that's what I would say. I was like, okay, assume Libby, let's assume that you're right. Let's pick a number that 6 does go into, and let's try to find a number where 6 goes into it, but 2 does not. So 6 goes into 6, 6 goes into 12, 6 goes into 18, 6 goes into 24. All of those numbers are also divisible by 2. So I'd say, haha, look, Libby, you're wrong, right? I know. I did that to Jayton this morning. She's like, I never said that. I'm like, I know, I'm putting words into your mouth and then saying that you're wrong. So we would start out by saying that. If 6 is a factor and 2 is not a factor, and then we would go through all the steps to try to say like, oh, look, there's no number I can find out there in the world that 6 goes into that 2 does not, right? So we would do that. Okay, 3, angle 3 is an obtuse angle. If we're trying to prove that angle 3 is an obtuse angle, and we're trying to assume the opposite to start with, what's the opposite of 3 being an obtuse angle?
It's just not an obtuse angle.
Yeah, so I had Jake Hodson this morning say angle 3 is an acute angle. Well, it could be a right angle, or it could be a straight angle, which is 180 degrees. So rather than listing all of those other combinations out, we'll just say angle 3 is not an obtuse angle, and that covers all of our bases. Does that make sense? So we are going to start by saying angle 3 is not an obtuse angle. Okay, and then we go through all the steps to try to show why it is obtuse. Does that make sense? And we're going to do by contradiction. Okay, this is just getting us warmed up. We're not actually doing this proof because we don't even know what angle 3 looks like. But this is just assuming the opposite. We're going to look and see what we have to do. Okay, good? All right, full-blown proof. Here we go. Example 2. Write an indirect proof to show that if negative 3x plus 4 is greater than 16, then x has to be less than negative 4. Okay, if we do the math, it just like if we would subtract the 4 over and divide by negative 3, whatever, we would end up getting with x is less than negative 4. But we're trying to prove this by doing a contradiction. So we're going to go through the steps like we did up here. The first step is show what we want to say. Okay, so we are given some information. We are given that negative 3x plus 4 is greater than 16, and what we are trying to prove is that x is less than negative 4. That's what our first step is, saying that what we're given, what we're trying to prove, that stuff. Okay, the second thing that we have is we're going to assume the opposite, right? Okay, so I'm going to start out with the word suppose. Let's suppose what?
X
What?
is
Yes, so we're going to rewrite the first part. So suppose that negative 3x plus 4 is greater than 16, but x is greater than negative 4. Now that's almost right. What's the opposite of less than? Greater than or equal to, actually, right? So if in the original, if this guy doesn't have an equal to sign, you're going to put an equal to sign. If it does, you're going to take it off, right? Okay, so that's how that works. Okay, so we're going to say, okay, but let's say that x is greater than negative 4, right? Okay, now I'm going to show in step 3 why you're wrong, right? Okay, so we have that. We're saying x has to be greater than or equal to negative 4. Now I'm going to show you why you're wrong, okay? So step number 3 is providing the evidence. And what we're going to do is we're just going to make a box, right? We're just going to plug numbers in, okay? All right, I'm going to plug 5 numbers in, and we're going to see what we get, okay? I want negative 4 to be my middle number, okay? But then we're going to do some numbers that are less than negative 4, some numbers that are greater than negative 4, okay? So less than negative 4 would be like negative 6 and negative 5, and then we have negative 3 and negative 2. We're just going to plug those numbers in and see what we get, okay? And we're going to provide evidence to show that x has to be less than negative 4, okay? All right, so if we plug negative 6, where are we plugging into, by the way? That thing right there. And we're comparing it to 16. So if I do negative 3 times negative 6 plus 4, this is 18 plus 4, which is 22. So I get 22 back out, right? Okay, let's just fill all these in. Negative 3 times negative 5 plus 4, that will be 19. Okay, negative 3 times negative 4 plus 4, like 16. Negative 3 times negative 3 plus 4 is 13, and negative 3 times negative 2 plus 4 is like 10, something like that. Okay? All right, so we filled those in. We've plugged them into the equation. Now we're going to decide which ones are correct and which ones are not correct. So we're going to compare this to 16, right? So these numbers greater than 16. Is 22 greater than 16? Yes. Is 19 greater than 16? Yes. Is 16 greater than 16? It's equal to, so no, it's not. It's not greater than 16. Is 13 greater than 16? No. Is 10 greater than 16? Okay. Oh, so according to our proof, according to the step above, we said that x had to be greater than or equal to 4. But look at that. Numbers that are greater than or equal to 4, which are these guys, did not work, which means we have a contradiction, right? We said x had to be greater than or equal to negative 4. But the only ones that didn't work in the problem were numbers that were greater than or equal to 4, right? So we can say in step number 4 for our solution that, I'm going to say, so if, what? How do I write out my
Negative
solutions?
3x plus 4 is
Yep.
greater than
If negative 3x plus 4 is greater than 16, then x has to be less than negative 4. Does that make sense? Yeah. We've just provided evidence. We've just shown x has to be less than negative 4 because that's the only numbers that work in the problem, right? Otherwise, they do not. Okay? That's it for that one. Okay, good? All right. Okay, on back side, we're going to do the top problem, but we're going to skip example 4 because it's kind of similar. So we'll just do this one. Example 3 is a big, long story problem. We're going to pull some stuff out of it. And I like this example because it makes sense, but this is a problem that I do not expect you to probably be able to do on your own because it's hard. But you should be able to, as we go through it, just at least understand where we're coming from, right? There's parts of this that you could probably do on your own, like you could probably figure out what you're given and everything. But there's one little step in there that's like, how do I go from here to here, okay? So just as we go through this, just make sure that what we're writing down makes sense to you, and that's all I ask, okay? All right, Javier asks his friend Christopher the cost of his meal and his date's meal when they go to dinner for prom, okay? Christopher didn't remember the individual cost of each meal, but he said that he knew that the total bill, not including the tip, was over $60. First period was like, what the heck? $60 for 2 people to go to dinner? That's crazy. Of course, it was Luke, and then he had to go on explaining to you can heat rice up and have a meal for 50 cents. I'm like, whatever, Luke, I don't really care. This is prom. I know, right? This is prom, so you kind of splurge a little bit, whatever, okay? So we know that Christopher and his date together, their cost is over 60, okay? So let's write like an inequality to represent that. Okay, so x is greater than 60. Let's do, instead of doing x, let's say that like Christopher plus his date, right? We'll write it like that because we have to talk about the individual cost of each one. So let's do two different variables. We'll do Christopher plus date. We know that that's greater than 60. That's what we're given. Okay? All right, what we're trying to get, what we're given, okay? Then what we're trying to prove, so the prove part is in the next sentence. It says, use indirect reasoning to show that at least one of the meals costs more than 30. Okay? So we're trying to say that either Christopher was greater than 30 or his date was greater than 30, right? Does that make sense? Okay, then that has to be the case, right? Even if Christopher's meal was only $10, his date would have to be at least 50 in order for the total to be over 60, right? So one or the other has to be greater than 30, right? That just makes sense that that's the case, okay? So we're going to do by indirect, by doing indirect stuff, number one. Number two is supposing the opposite, okay? So let's start with suppose. Suppose that, what? C plus D is greater than 60 because we have to have that to start with. Suppose C plus D is greater than 60, but what? C is less than or equal to 30. What's the opposite of or? And D is less than or equal to 30, okay? So if we're assuming the opposite, we're saying that both of them are under 30, which we know can't happen, right? If both of them are under 30, then the whole bill won't be 60, right? And then Kyle goes, but he must have brought like 2 extra people or whatever, and then he was cheating on the girl that he was going to prom. I'm like, whatever, Kyle, I'm not getting into this drama here, okay? So, whatever. C is less than 30 and D is less than 30. That's what we're assuming, okay? All right, now, this is the tricky part. This is the evidence part, and this is the part that's like the kind of far-fetched part that's hard to come up with, okay? We're looking at C plus D together, right? C plus D. So what I'm going to do is I'm going to look at these two pieces, right? And I'm going to kind of like add these two equations together, right? So if C is less than 30 and D is less than 30, then if I take C plus D and add them together, that has to be less than or equal to 30 plus 30, right? Like this added to this has to be the same as this added to this, like the inequality symbol, right? So C plus D will be less than 30 plus 30, which means if we simplify that C plus D is less than or equal to 60, right? If this right here is true, then we have this as a result. But that contradicts what we said, right? Mm-hmm. We're saying that C plus D has to be greater than 60, not less than 60, right? Mm-hmm. So there's where my contradiction is, right? If this is true, then there's no way that it's going to be greater than 60, right? Because it just doesn't add up. So that's my contradiction. And then step number 4 is writing out the solution. So we say for our solution that if C plus D is greater than 60, then C is greater than 30 or D is greater than 30. Does that make sense? Mm-hmm. Okay, kind of hard to, like that middle step was kind of a weird thing where we're adding those two equations together. That was kind of hard to generate by yourself, but does it make sense? Yeah. Okay, that's all I ask. All right, we'll skip example 4. We'll go straight to the homework. I'm going to go ahead and do this for the people who are watching this video. You guys don't have, oh, you do have this paper, yeah. Okay. For practice side, do 1 and 2. Those are the where you're just writing the opposite, right? You're just starting off the proof. You don't actually have to do the proof. Number 3 is going to be really similar to the proof that we did with the table. You don't have to do number 4. And then try number 5. We might have to go through that one together in class, but at least kind of read and write down your given stuff. So 1, 2, 3, and 5 on that page. You can skip 4. Okay. On the back side, 1, 2, 3, 4. That's again the write the opposite. So you can do all of those. 1, 2, 3, 4. 5 is going to be the same as that table one, and then you can skip 6. Okay. So you can skip 4 on one side, 6 on the other side. Okay. Good. There you go. It's kind of short. Okay. Everybody say bye, Haley and Jalen.
Bye.
Bye.